Another example of this collaboration between government and industry and universities is highlighted here. And this is in the area of packaging. And we've developed a packaging technology corridor here along the Northeast. We do research in packaging at our IBM research facility in Yorktown. We do development in East Fishkill. We now have an advanced packaging R&D center in Albany that's now part of that Albany ecosystem. Our manufacturing has been done up in Canada, in Bromont, Canada. And we had a partnership with the Canadian government to establish an R&D center there, but it's focused on R&D for how do we improve manufacturing yields and manufacturing quality. And that's the Micro Innovation Center, and that was just launched last year. So two different government partnerships, one with the US government, or the New York State government, one with the Canadian government. And this one actually is in partnership with university that's there in Bromont, Canada. So really quite an ecosystem. This gives you a view of how our operations have evolved. We have 3 research centers, Almaden, Yorktown, and Zurich, which feed my activities. I have development centers in Fishkill, in Burlington, and I mentioned the activity here in Bangalore. The Advanced R&D Center in Albany. And then our partners have 3 facilities, Korea, actually Samsung, I should put Austin here. They have an Austin facility as well. ST Microelectronics in Caux, France. And then as a result of this growth of this technology corridor and support from the New York State government, Global Foundries needed to put a new manufacturing facility somewhere, and they chose Malta. They gave them very quick access to the Albany Nanotech Center and support from New York State. And this is a very, very big facility. I just want to say just a few words about our Bangalore facility. As I mentioned, it started out in the area of what we call compact modeling. So design enablement, developing the design kits that designers can use on our technology. But it's branched out, as I mentioned, over the years. We're doing extremely sophisticated TCAD and atomic modeling of these devices. These films that we use, high key metal gate, require atomic level type of engineering to be able to get the right performance, the reliability. Morale, who here's in the front, leads that activity, and he's been doing a lot of atomic modeling to understand how do we optimize the films with the right materials so that we can achieve those performance and reliability requirements. I mentioned the extension into computational lithography, and then process and design device characterization. But it's not just about semiconductors. We actually have an entire ecosystem going on in Bangalore. It starts out with semiconductors, but it involves EDA, so the enablement of technology for design. We have design going on both for custom logic. This is for parts that we sell out in the marketplace, and then our own usage, our processors and system ASICs, and then systems engineering. And one of the nice things in Rajesh's organization, he has both the designers and the technology guys, and they really work closely together to figure out how do we optimize the technology and the design so that we get the best results for the product in terms of cost, performance, power, but that technology is manufacturable, which means we can produce it at an affordable cost. And that's very important. And you hear out in the industry a lot of discussions about being virtual IDMs. We're an IDM, so we're vertically integrated. One of the challenges has been yield on some of the recent technologies. 40 nanometer, 28 nanometer, very well known in the industry. And you see a movement in the industry in both the foundry and fabless model to get to a much closer relationship so that you can achieve those yields and those product performance results. So as Morale coins the phrase, in Bangalore and in Fishkill, we've got everything going on from atoms to devices to design and to systems. And being able to establish that type of ecosystem here in India, even if it's from a virtual perspective, can have tremendous benefits because all of it is synergistic and can feed on each other. And this just takes you through some examples of what are the key elements for growing the ecosystem. And it starts really at the bottom, having a competitive base technology. And it really should be a base technology that's aligned to the product needs of your business. Ours is aligned to our business, aligned to the needs, say, of India. Then on top of that are the foundry services, the ability for designers to be able to prototype their technology in that fab So masks, MPWs, the ability to get packaging and test, and of course, having PDKs, design kits, to be able to design in that technology. Built on that is then the foundational IP. So this is libraries, ARM libraries, for example. We partner with ARM in developing IP that customers can use to develop their products. And then you start to get into the higher level design enablement and then design applications. Some of this can leverage the existing capabilities that I think are in India. For example, fabless, you already have quite a number of fabless companies, and trying to figure out how to leverage those to build a bigger product portfolio. This just shows, again, it's kind of a similar view, but it kind of walks through sort of an end-to-end on what the key modules are for technology. As I mentioned, it's access to leadership technology, manufacturing methodology, controls, yield methodology. It requires training, and this doesn't happen overnight. So we've done this now with a number of companies, and the key lessons learned that we have been the use of round-robin wafer exchanges back and forth to help a new fab come up, supporting from a failure analysis perspective, rotational training of people to build up the skills, and then product level transfers, being able to take a product that's manufactured at one site, transfer it over and ramp it so you can compare the yields and learn from each other. And then there's an IT infrastructure that's required to support the fab. Those are basically the key elements that are needed for a foundry. From a design house perspective, you have design IP and design tools, and then all of this has to be packaged. And that can be done in-house, or it can be done in a basically a outsourced mode, but it requires wafer bumping, test, and packaging technology. Let me just show our ecosystem so you can get an idea just how broad it's become. And by the way, it didn't start out this big. It evolved over quite a number of years. But it started at the center with manufacturing and technology development. And we have our partners, Samsung, Global Foundries, and ST Microelectronics. We added what I would call the next ring, which is the manufacturing capability. So that's our Common Platform Alliance with Samsung and Global Foundries. And then the EDA capability for customers to be able to design in our technology. And then finally, we expanded into many other areas over the last 5 years. The research collaborations, things like computational scaling, which support the computational lithography mission here in Bangalore. Government partnerships, tool and equipment partnerships, which I talked about at length. And then we've got now a pretty rich ecosystem of packaging joint development partnerships. By the way, if I showed you this 3 years ago, this corner would have been empty. All of these were partnerships that we've established over the last few years. So now, what does it mean for India? Why would this be important to have? And I've given you my perspective here. You may have some different thoughts, but I think some of the key elements could be as follows. Addressing import-export supply gap. My understanding is your domestic demand is projected to be about 400 billion by 2020. Your domestic production is expected to cover only about 100 billion. So that's about a 300 billion gap. And if you think about the gross profit that the foundries make, it's up in the range of 40, 45%. That's a lot of profit that's going somewhere else in that product that you'd be shipping. This is true for us, and it's true, I think, for you. You have control of your technology. It's virus-free. That's very important for IBM. That's why we maintain our own supply of technology. The other reason we maintain that supply is sourcing stability. We have control over our supply, and that's a huge benefit. It provides a platform, and there's potential collaborative models that I can imagine. We had some discussion before this meeting on for how it could be a platform for spurring additional scientific innovation and research development here in India with the universities. It's great for job creation. That's the main reason New York State invested in the Albany Nanotech Center, helped to support the Malta facility. And it's not just about the jobs in those factories. They end up spawning easily 10 times that number of jobs around them, because you bring in equipment suppliers, material suppliers, you bring a lot of revenue into the community, which generate jobs throughout the community. Some possible focus areas, from our experience, and I think Dave will touch on it, that we see, set-top boxes, smartphones, and I don't mean taking on Apple or whatnot, but there are components that could be manufactured in an analog mixed signal RF application that could be easily done doesn't require a leading edge, state-of-the-art, multi-billion-dollar factory. Tablets, smart meters, micro ATM, smart cards, and sensors are all, I think, great applications that could be part of a startup foundry operation. So to summarize, CMOS scaling will continue. I hope I can convince you of that for the next couple of decades. But it will require innovation and collaboration and new disruptive technologies. I highlighted some examples of those. We're focused on delivering solutions to our customers that give them the maximum value. That's why we manufacture our own technology, so we can really optimize it so that it gives the best value to our server business. And a fab can be a catalyst, as I highlighted, for a broad electronic system design and manufacturing ecosystem. So thank you very much for your time and attention. I think I'll turn it over to Dave and to give you some perspective on the RF analog mixed signal.